Hi, welcome you to the interface concept session. Here, another kind of interface that is called marker interface or tagged interface. So, this kind of interfaces will not have a members in the sense in Java method and variable. It does not contain methods and variables. So this kind of interfaces are called marked interfaces or tagged interfaces. For example, java.io.serializable, java.language.clonable, java.rma.remote, etc. So these are all default interfaces which is defined inside the Java API libraries. They are used to provide some essential information to the Java virtual machine so that Java virtual machine may perform with these tagged interfaces for performing useful operations, right? Here how serializable interface is written. So this is first one is serializable interface. So here we have to use that serializable interface by using this kind of syntax: public keyword interface name serializable interface, then we can define any number of statements here. Like that we have seen clonable interface in the cloning object cloning method. There it is any class, okay, then class name, then which implements clonable interface. Okay, so this is done by using this kind of syntax. So here the interface is defined with within another interface that is called nested interface. So interface printable is created here, then inside that I am creating abstract method print which is belonging to the interface printable. Then I am creating another one interface inside this interface that is called message. Okay, so message is an interface inside the another interface printable, so it is called nested interface. The message is having the method msg, which is also abstract method. So when you are implementing the uh, interface printable, right? So here you see we are creating the class nest int which is implementing printable interface dot the nested interface inner interface is here message. So you have to use the dot symbol to mention that nested interface. Okay, so then we are implementing the method msg which is belonging to the inner interface which is having some number of statements. Here only one statement. Then we are implementing the method which is defined in the printable interface with a single statement. Then I am creating the main method, right? So here the object is created by using the class nest int that is given here. Then I am calling the method msg which is available inner side of the interface. So here it is calling, so the control is passing over here. Then automatically this will override this method which is available inside the interface. Then the first statement is displaying, then print method is invoked which is passing the control over here. Once this is called, then which is overriding this print method, then this statement will display. Okay, so that is the nested interface. Here you will get these two lines as a output. Then we have seen the ambiguity in Java. Here the class is implementing two interfaces, but both have one or more variables with same type and also similar name. For example, here interface 1 is defined and which is having the variable string data type. Name is here car brand. Here we are giving the value, right? And interface 2 is defined with the variable name is car brand, data type is string. So both are, you see, having the same data type and a similar variable name. Then we are assigning some value. Here the class is implementing the interface 1 interface 2 both. Then we are invoking the method, I mean defining the method car which is calling the variable name with the value which is defined over here. You see here this method is confusing which variable is right. This variable is belonging to either interface 1 or interface 2. Okay, so that is the thing here. So when you are calling this method, then the variable belonging to right any one of the interface, right? So the confusion is occurring here. So what will happen, you will get the error. You see, reference to the car brand is ambiguous. Okay, so ambiguous in the sense more than one interface is having similar variable name with a similar data type. So you are getting the error. How do we solve this? So it can be solved by using here the interface name. Okay, in front of the variable you have to use interface name. This belongs to first interface int1. Then here we are calling the variable which is belonging to int2. So we can reference that variables by using the interface name, right? int1 and int2. It will access the value of the variable which is defined inside the int1. This is accessing the variable which is defined inside the int2. Now when you are invoking the method car, right, so which is passing the control over here, then you will get variable names here with the value defined over here. You see, which is giving you the name interface 1 and interface 2, right? This is the way to solve the ambiguity in Java, but it is not possible in the class. And here again we are defining variable name x equal to 10 in the interface A. Interface B is having x equal to 100. Then class high is implementing both interfaces. Here you see we are trying to access the variable x, but x is ambiguous. You are getting the error here. Reference to x is ambiguous because both variable x in interface A in interface B are matching, right? So to avoid that, as I told you, you have to use the interface name to access the variable, right? Then here B, which is accessing the variable name inside the interface B. So both are giving its own value 10 and 100. So you can solve the ambiguity using the interface by using the interface names. Here one more thing. Until now we have seen only concrete class, okay, which is implemented the uh, interfaces. Now we are seeing that abstract class is also implementing the interface. You see, interface is defined with variable x and abstract method here add. Then here abstract class is created which is implementing the interface A. Then here I'm implementing the abstract method add right inside the abstract class. So here concrete method which is created, which is implementing the add method defined inside the interface with variable name 100. Then here you see, this is the indication that we are accessing the variable x from the interface A, right? Here this x is referencing the variable which is defined inside the method add inside the class. Okay, then I'm creating one more class, driver class, which is extending the abstract class B, right? Extending the abstract class B, which is inheritance concept. Again main method is created here. Then I'm creating the object variable by using the class high, then which is having the accessibility of the uh, parent class B, right? So it is accessing the features of this one. Once it is accessing the features of the parent class, the parent class B is having the accessibility of interface A. So you see, through this high we are accessing the parent class B. B is having the accessibility of A, so high can access both class abstract class B and interface A, so through the inheritance concept. Then we are invoking the add method. Add method is passing the control over here, then it is overriding the abstract method add. Then you will get two statements here available, right? One is a dot x 10 will be printed. You see 10 is printed, then this is belonging to the variable which is defined inside the method, that is printing the value 100. Then here you see inside the class high we are accessing the interface a variable x 10. So here 10 is printed. So through this we should observe abstract class also can implement the interface, right? Thanks for watching.